Karen. I don't know Karen.
Yeah, he's a regular pickup, that's why.
Oh, regular. One of those kids. Sorry. All right, Tyson, what'd you get for number 3?
86.19.
86.19. Can I round it to 86.2? You got any issues with that? If I go nearest 10. All right. Mason, what about number 4?
Undefined.
Undefined. All right. Jackson, do you know when it's going to be undefined? Right here, this will tell me whether you be AP Calc or CCP. This answer right here. No pressure. Not sure? Yeah, sure. Connor McCulley, do you know when it's going to be undefined?
That number is over 1.
Exactly. Go tell Jackson that. He thinks he maybe should pay attention. When that number is this number here that we're taking the inverse sine of, if this number is bigger than 1 or less than -1, so 3.2 or -3.2, we can only take the inverse sine or cosine of a number that is less than between -1 and 1. 0.876, that's fine. 0.25. Now we can take the inverse tangent of anything. Inverse tangent of anything, so that doesn't matter. So it's just inverse sine and inverse cosine. Now cosecant here, and I think we did this one yesterday, but one thing you got to watch is you cannot do this. You cannot do 1 over inverse sine of 1.45. That'll still give you undefined. That'll give you an incorrect answer. That won't work. What you got to do for these is you got to make sure you just convert it to inverse sine, and then you flip 1 over 1.45. Okay? Now, is that number, is 1 divided by 1.45 going to be less than 1? Yes, so we can take the inverse sine of it. And so I can do inverse sine 1 divided by 1.45, and I get 43.6 degrees. So I get 43.6 degrees. So secant, inverse secant, that would be inverse cosine of 1 over -2.6. Okay, 1 divided by that. All right. Tessa, let me know what you get, please. 112.6 degrees. All right, for that. Now, if you do cosecant, I'm just hopping down to number 8. Cosecant is 0.5, which is going to be inverse sine of 1 divided by 0.5. All right, hit that. Thomas?
Well, it's going to be 2, so it's greater than 1.
So what's my calculator going to say?
Undefined.
Let's say, yep, error. It's going to say undefined. So it's going to be undefined. So correct. So sometimes you're going to see that and you're just going to kind of go through the motions. I just want to make sure you understand why it comes out the way it does. Undefined. For that. All right, now these next two, and I told you we didn't get to these. These are like 79 and 81, I believe. But let's hit them now. This exact value means no decimals. This will be on the no calculator part of the test. So you got to be able to construct a diagram to demonstrate this. So it's basically saying, I want to find, you can only take the cosine of an angle. You can only take the sine of an angle. This inverse tangent, I want to find out what angle has a tangent of 3/4. Well, first of all, where's inverse tangent? Where's the inverse tangent defined? Okay, what values can I get back for the answers? Only from -pi/2 to pi/2 or -90 to 90. So this is positive. This angle has to be in quadrant 1. Well, tangent is still and always will be opposite over adjacent. So you're just going to draw a triangle in angle 1 whose opposite side is 3, whose adjacent side is 5. And so I don't know what the angle is, but I know opposite is 3, adjacent is 4. And I want to know the cosine of that angle. Well, cosine of the angle, that's never changed. It's still going to be adjacent over hypotenuse. We still got to figure out the hypotenuse, but we can figure that out because you can use the Pythagorean theorem. So you can use 3 squared plus 4 squared equals x squared. You get 25 equals x squared. A lot of you already know that it's going to be a 3, 4, 5 triangle. So that's going to be 5. So what is the answer? What is the answer? So y equals the cosine of the inverse tangent of 3/4. So in the end, my answer is adjacent over hypotenuse. It is 4/5. Now, if any of you just typed it in your calculator, what'd your calculator spit out? We have written down. Okay, Bravo will say 0.8. Okay, on it. So but now, you're not gonna have your calculator on this part. You can use it as a check. So if you did cosine, inverse tangent, 3 divided by 4. Let's say 0.8, 4/5. All right, how about number 2? Take a look at this one. See if you can set it up. And if you're not quite sure, just hold on half a second. First of all, I guess you need to think which quadrant it's going to be in. And if you're not sure which quadrant it's going to be in, wait. If you're positive, go ahead and set it up. Because we want the inverse tangent of a negative number. Yes. We have it down. I'll go back and get it. Oh, okay. So Dominic just said we didn't hit the inverse tangent. So let me go back a couple of slides and see if we can hit it real quick. All right, this is the case here for the inverse tangent where we restrict the domain so that we get all the y values, but we don't get anything that repeats. This is should be right above what we're working on. It should be right above that. So we restrict the domain to negative pi over 2 to pi over 2. Because that allows me to hit everything without repeating. And so over there on that right-hand side, this is what Dominic made mention of that we didn't write down and we didn't get to. So that the inverse tangent, the domain will be negative infinity to infinity. The range will be negative pi over 2 to pi over 2. Okay? For this graph here, which is y equals tangent of x, the domain, and actually since there's asymptotes there, it will not include the negative pi over 2, pi over 2, but it'll go to and from there. And then the range is everything. The range is negative infinity to infinity. Okay, and then remember for the inverse, it flips. So the domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. Okay. So I can plug in anything into the tangent function, but I'm only going to get answers back from negative pi over 2 to pi over 2, which is negative 90 to 90. That's a 9. What quadrants are those? Negative 90 is right here. 90 is here, so everything has to be in quadrant 1 or quadrant 2. All right, Dominic, thanks for pointing that out. So now, what quadrant do you think that'll be in? It's got to be quadrant 4 because it's a negative number, and we're taking the inverse tangent, which is different than cosine. So I'm going to draw this out. This is my angle. Opposite over adjacent. Well, it's going to be negative 3 over 1. Okay, just think of it like that. So opposite's 3, adjacent's 1, or opposite's negative 3. I think what you take the sign's going to be. Sign's got to be opposite over hypotenuse. I need to know the hypotenuse. 1 squared plus negative 3 squared equals r squared. 10 equals r squared. Square root of 10 equals R. So my sine, this is gonna equal -3. -3 over square root of 10, or -3 radical 10 over 10. All right, for that. I hope those make sense. We're gonna hit it a little, one more time here in the day 2 notes, but just hopefully it gives you at least a little bit of an idea, okay, for this. All right, so for day 2, that whole front is always it's always a little bit of a battle because to kind of figure out that range part, like which values can it come back to. So I just like to hit it again. This is really no different than we covered yesterday for the first part of it. Why do we restrict the domain? Why do we restrict the domain? Mason, have I explained this correctly yet?
So you only get one answer.
So we only get one answer. So basically I gotta get all the y values. So right now, we're only gonna consider this from -pi/2 to pi/2. That's why when we do the inverse, you can't get an answer at 3 pi/2 because that's not part of the restricted domain. It's outside of it. So only anything can come back in between those two. Allows me to get one answer. Now, and this does a really good job. If you actually go through and read it, hopefully it'll do a good job of explaining what's going on. Inverse sine, you can only plug in numbers between -1 and 1 for the x. You're only going to get back answers between -pi/2 and pi/2. Never anything else. Okay? Again, they're just going to list the domain. They're going to list the range. There's the function and its inverse. You don't need to memorize that or graph it. It's just there for your information. Cosine's different though. If you restrict it from -pi/2 to pi/2, it doesn't give us all the possible values. So we have to change it to 0 to pi. That's why it's a little bit different. The domain is still the same. I can only plug in numbers from -1 to 1, but I will get back answers 0 to pi, which is quadrants 1 and 2. So for inverse sine, you're going to get answers back in 1 or 4. For inverse cosine, you're going to get back answers in 1 or 2. Okay? And then for inverse tangent, okay, it's the same as sine. Which means I'm going to get back answers in 1 or 4 because I, again, restrict it from -pi/2 to pi/2. So that's kind of how those are different. Okay. And here's that part on the right-hand side. Tangent is different because, remember, it goes from -infinity to infinity, the range of the original. So I can plug in anything into the inverse tangent. I'll only get answers back from -pi/2 to pi/2. All right, and there's your 2 graphs there. All right, once you got that, flip it over on the back. Take a look at number 1 and 2. I want you to think, do you know what that's asking? Do you know how to answer it? It says y equals the inverse sine of -√3 over 2. You know what it's asking? You know how to answer. All right, see if you can think of the answer. And I want the answer in radians. So if you think about it in degrees, but convert it to radians. All right, see what you come up with. We're just doing the opposite of what's on those 10-point quizzes. Okay, hopefully you kind of make that connection. So if I said what's the sine of, and I said 60 degrees. Can you think what's the sine of 60 degrees? So you draw it out, right? So the sine of 60 degrees, Tessa, you know what it is? It's square root of 3 over 2. But now I'm going backwards. I'm going to say we want the inverse sine of negative square root of 3 over 2. So what angle has a sine of square root of 3 over 2? Well, we want the negative square root of 3 over 2. So for inverse sine, if anything is positive, it's in quadrant 1. This means it's in quadrant 4. So it means that the opposite side is negative square root of 3 over 2. This is the angle I'm looking for. Well, what is that angle going to be? In degrees is okay for now. In degrees is going to be 60 degrees. But since we're in quadrant 4, it's not 60, we're going to label it as negative 60. Since I want my answer in radians, the final answer will be, Ty?
Negative 5 or 6.
Not 6. That would be 30 degrees. Negative pi over 3. So the answer is negative pi over 3. Negative 60 degrees. Negative pi over 3. So we're going backwards. So instead of saying, all right, instead of giving you the angle and you're giving me this is why we're going to keep hitting those over and over and over again. Okay? You kind of got to have them, be able to do them at any point in any situation. All right, inverse cosine of radical 2 over 2. What angle has a cosine of square root of 2 over 2? Since it's positive, it has to be in quadrant 1. Okay, square root of 2 over 2. What type of triangle does that deal with? We only got 2, 30, 60, 90, or 45, 45, 90. So this deals with a 45, 45, 90 triangle. It means the adjacent side is radical 2 over 2. So you're going to get 45 here. That means you'll get 45 here. That's going to be pi over 4. Positive. All right, secant of negative 2. Inverse secant of negative 2. Well, we don't have any inverse secant. So we just think about it in terms of cosine. So y equals inverse cosine of negative 1/2. All right, think about that. Ooh, I want to see what you come up with. Inverse cosine. Inverse cosine. Close. All right, anybody think they could have it and they'll answer it? Got it. 2 pi over 3. All right, Tyson, you think he's right? Or you have no idea?
I think he's right, but
You think he's right?
yeah.
He's right. 2 pi over 3. Because what is that in degrees? Because that's just going to be helpful. It's 120 degrees. So what do we got there? Secant inverse cosine is in quadrant 1 or quadrant 2. Since it's negative, it's in quadrant 2. That means that's negative 1/2 adjacent side. That means across from it's 30. That means this angle is 60. So that means the whole angle here is 120. Okay? And so that means it's going to be 120 or 2 pi over 3. All right, this is kind of mean of me. Inverse sine of square root 2. The answer is undefined. Okay, sometimes you see square root of 2 and you think of the 45. But if you realize that the square root of 2, second square root 2, it's actually bigger than 1. Okay, so it's undefined. So that's why. It's not really part of either of the triangles. Undefined for that. All right, it takes a couple times just to get this to sink in. It takes a couple times. All right, now don't put these in your calculator yet. Like, don't get ahead of me, please, please, please. Just wait. The point of this is, I know you can type them in and it'll spit out an answer. I want you to recognize in which quadrant the answer will be, or what do you think the answer will be. Okay, so for the first one, go ahead and type that in your calculator. It's absolutely fine. What's the inverse sine of 0.2? Nearest tenth is fine. Allie, let me know what it is to the nearest tenth. I just do 11.5. Okay, 11.5. All right, without typing in your calculator, you should be able to tell me the answer to the one right there, negative 0.2. Okay, or what quadrant it will be in. Kaden, do you know what the answer will be?
I don't know what the answer will be, but I know what quadrant it will be in.
How about that?
The second one?
The second quadrant. Okay, good. Now go ahead and hit inverse sign and then, no, you said second quadrant?
No.
Change it. It's not second quadrant.
The fourth.
There you go, fourth quadrant. All right, do inverse sign of negative 0.2. What's it tell you, Caden?
Negative 11.5.
Negative 11.5. And think why. Here's why, because this means that the y value is 0.2 here. Well, we're gonna have to have the same angle, except it's gonna be negative. Oh, that's a bad triangle, sorry. Same thing here, so whatever that angle is, it's gotta be the same but opposite. But yes, one's in quadrant 1, the other one's in quadrant 4. All right, so now the second one. All right, again, the range 0 to pi or 0 to 180 for cosine. Inverse cosine of 0.35. You absolutely have to use your calculator. It's not a unit circle value. So what is the inverse cosine of 0.35? Nathan to the nearest 10.
It's 69.5.
Okay, so it's 69.5 degrees. All right, I know yours says sine. It should be cosine. All right, you can mark it off on the evaluation. All right, what quadrant is that answer going to be in? Esther. Second quadrant. All right. You know how we can figure it out without just hitting it in our calculator? It's not going to be negative 69.5 because that's in quadrant 4. All right. So just think about this. It's going to be, here's my angle, and that is 0.35. Okay. This angle is going to be exactly the same as that angle. If you take 180 minus that, that'll give you your answer. Okay, same thing here though. If I do hit inverse cosine, negative 0.35, I get 110.5, which would be 180 minus that. These numbers need to be between negative 1 and 1, or else it's undefined. For tangent, you can take the inverse tangent of anything. Okay? All right, so use your calculator, see if you can figure out, and then figure out the other one with or without your calculator. That doesn't matter. With or without your calculator. Audrey, you got the first one?
73.6.
73.6, and then you got negative 73.6? Or the second one? All right, one's 73.6, one's negative 73.6. Okay. All right. So again, we're just trying to hit what type of answers are you going to get back. All right, we talked about this earlier. Let's hit it again. Y equals the sine of the inverse cosine of 4/5. Can't type it in your calculator because you're not going to have your calculator for this part of the test. So you got to understand it. Can you draw the diagram and then figure it out as a fraction? Okay. What quadrant will this be in? The inverse cosine of negative 4/5. Clev, what quadrant will that be in?
2.
Yes, quadrant 2. Quadrant 2. And that means my adjacent side is 4. My hypotenuse is 5, and you can put a negative there. Okay. Now, I want the sine of that angle. Sine is always the opposite over hypotenuse. You got to figure out what that opposite side is. And then kind of go from there. And x squared plus 4 squared equals 5 squared. And we get x squared equals 9, x equals 3, 3, 4, 5 triangle. So that's 3. So my answer will be 3/5. That's what you need to say. Now, you could use your calculator just to kind of say, all right, am I on the right track? Because really, what is the inverse cosine of 4/5? What angle is that? Negative 4/5. Okay, it is 143 degrees. And what do you think is going to happen when I hit the sine of that? I get 0.6, 3/5. Okay, so it matches up. All right, last little bit here. Wait, all right, what do you think that answer will be? Just take a look at that. Don't type it in your calculator, do it without it. See if you can figure out what it's asking. Right here. So starting there, Thomas?
No, I'm good.
You're good? Okay. You're good. Now, anytime, I'm just gonna keep everything in degrees. Okay, I know earlier we did it in radians. But, no?
It would just be 1/2,
That makes us 1/2. Now, how'd you figure that out?
because the inverse sine of 1/2 is pi over 6, and sine of pi over 6 is 1/2.
Okay. Inverse sine of 1/2, and he even put it in radians. What angle has a sine of 1/2? It's actually, I'm just gonna use 30 degrees because I have degrees in there if I need it. And what's the sine of 30 degrees? 1/2. So that answer is 1/2. All right, number 2, very similar. What angle has a cosine of 1/2? This is important that you can think through that and figure out what angle has a cosine of 1/2. Okay. What angle has a cosine of 1/2? See a lot of thinking here. Oh, Alex, you know?
60 degrees?
60 degrees. So now we're taking the cosine of 60 degrees. What is the cosine of 60 degrees? It is 1/2. Okay, for that. Now we're going to start with the inverse cosine, okay, and then take the cosine of 45 degrees. All right, this is like the ones on the little 10-point quiz. What's cosine of 45 degrees? Okay, adjacent side, 45, 45, 90 triangle. Connor, you remember cosine of 45?
Square root of 2 over 2.
Square root of 2 over 2. So now we say y equals inverse cosine of square root of 2 over 2. What angle has square root of 2 over 2? That would be 45 degrees. All right, now I kind of set you up for failure on this last one. Let's see if you can figure this one out without making the mistake. See if you can come up with this last one. There's 3 people. It's not undefined. I can't get down. It's too good today. Alex on a roll. All right, first of all, what is the sine of 120 degrees? Sine of 120 degrees. Katie, what's the sine of 120 degrees?
Square root of 3 over 2.
Okay. Square root of 3 over 2. There is an angle that has square root of 3 over 2. What is that answer going to be? What's the inverse sine of square root of 3 over 2? Okay. What angle has a sine of radical 3 over 2? And what does our answer have to be, Alex?
60 degrees.
60 degrees. Now, here's where you gotta watch. 120 does have, the sine of 120 is radical 3/2, but you cannot have 120 degrees as your answer. Okay, because that is not in the range. It is not between -90 and 90. So this is one you gotta watch, because right here, a lot of times, like the answer was always what we started with, like 45 degrees, 45 degrees. You gotta watch, 120 degrees here doesn't mean it's 120 there, for that. But so it's gonna be 60 degrees, because that's where that range is. All right, couple things here. I'm gonna give you this review sheet here in a second. But looking over those graphs for the other day, I'm not 100% convinced you know what you're doing. This is a big part of the no calculator test. So 2 problems. This is the only homework you got. 2 problems. Number 56 on 578, graph it over 1 period interval. 589, number 60, 2 period interval. You have to put down the key points. You have to indicate what your scale is. You can't just put a little X, Y axis and a squiggly line, okay, and some random points. Okay, so I need to see if you know what you're doing. Okay, for that. Now I am going to hand you this review sheet. I'm going to go over a couple of things tomorrow, and then essentially you're going to get a good chunk of the period to go over things. So I'll hand this to you now, and you can read through it. It tells you what's on the no calculator test and what's on the calculator test. It does give you review problems. These are not due tomorrow. They'll be to be done at your discretion. So these are the only 2 problems you need to do. But do them very